The star Betelgeuse, a crimson super-giant situated in the constellation. Astronomers have long been fascinated by Orion and skywatchers alike due to its immense size and luminosity. If Betelgeuse were positioned where our Sun is, it would extend all the way to Jupiter's orbit, a testimony to its enormous size. Despite being approximately 642 miles away light-years from Earth, its vast size makes it one of the brightest stars observable to the unnamed eye. However, in recent times Betelgeuse has displayed unusual patterns such as unexpected dimming and brightening cycles, which numerous scientists believe that the star is approaching the conclusion of its existence. The esteemed physicist Brian Cox recently made a groundbreaking announcement that Betelgeuse is on the verge of a devastating explosion anticipated to occur within the next 2 weeks. This occurrence, known as the supernova, will mark the end of Betelgeuse's life, but it will also supply an opportunity like no other for scientists to examine one of the most extraordinary and powerful phenomena in the universe as a colossal star nearing a due explosion. Betel falls into the category as a red supergiant, one of the largest and the vast majority of stars in the universe. It has occupied astronomical radar for hundreds of years, but its recent and unpredictable shifts in brightness have sparked speculation that the star is getting ready for a supernova. When a star like Betelgeuse, its core reaches its end of life, collapses under its own gravitational pull, resulting in a massive explosion that releases a significant amount of energy, radiation and stellar material into space. Betelgeuse's impending explosion is anticipated to be a Type II stellar, in particular, a supernova explosion that takes place when the center of a massive star collapses. This core, the collapse sets off the release of neutrinos and radiation, creating a shock wave that tears the star apart. The explosion will be so spectacular that it could be visible from Earth without the aid of telescopes, potentially even shining brighter than the moon in the night sky for months or weeks. During such an event would typically be disastrous if it occurred near one another. Betelgeuse distance from Earth, about 642 light-years, means that although the explosion will be visible and dramatic, it will not pose any threat to life on our planet. The event, however, promises to reshape our understanding of supernova. And one of the cosmic phenomena is a supernova, of the most powerful occurrences in the universe, releasing more energy in a few moments that exceed the Sun's control over entire lifespan. Betelgeuse explosion will not only be a spectacular celestial display, but it is also an important milestone for science. Researchers are eager to observe this rare event from its very beginning, utilizing various ground and space-based telescopes, including the Space Telescope Hubble and the James Webb Telescope for Space JWST, to gather as much data as possible. When Betelgeuse explodes, it will emit a wide range of radiation, from visible light to gamma rays. One of the most important parts of the supernova, will it be difficult to detect the neutrino influx? Subatomic particles that rarely interact with matter. Neutrinos from a supernova can arrive on Earth before the light from the blast because of their ability to pass through nearly everything without being affected. Observatories like Japan's Super Cameo Candy and the Ice Cube Neutrino Observatory in Antarctica are preparing to detect these neutrinos, providing a advantage in observing the juices of B's final moments. Include the explosion as well. Will provide important information about the formation of heavy elements. When stars explode, they create and disperse elements like gold, silver, and iron, materials made of uranium that are vital to life as we understand it. The examination of Betelgeuse's supernova will offer real-time observations of this element formation process, which is vital for grasping the formation of planets and the universe's chemistry. Although Betelgeuse supernova is not expected to have detrimental effects on Earth, it will interact with our planet's atmosphere and magnetic field in intriguing ways. The energy burst from the arrival, in particular the explosion of cosmic rays and charged particles, could result in more intense auroras, expanding the regions in which the southern lights are visible. While these cosmic rays may or may not have an effect on satellite communications and some few earthly technologies, the disruptions are expected to be minor and short-lived. One of the most thrilling aspects of Betelgeuse explosion is that everyone will be able to see it on Earth, in addition to professional astronomers with advanced equipment. For weeks or even months, Betelgeuse is envisioned as the brightest object in the night sky, possibly even visible during the daytime. This spectacle will engage not just the scientific community but also skywatchers and the General public igniting renewed interest. Inner astronomy and the cosmos. Astronomers have long speculated about Betelgeuse demise, but Brian Cox's recent declaration adds a newfound sense of urgency. In the coming weeks, observatories worldwide are preparing to investigate every phase of the supernova. The scientific data collected could be extremely useful, changing our understanding of stellar evolution, core collapse, cosmos distribution, and the supernova. Betelgeuse supernova will result in matter provide scientists the chance to refine their cosmic distance models. Being relatively close to Earth, it offers a unique chance to determine how energy travels through from such explosion space by paying attention to the light and radiation from the supernova as it interacts with the interstellar medium, the gas and dust that exist between stars. Astronomers will gain a clearer understanding of the scale of the universe. In particular, the event will provide an excellent opportunity to investigate dark matter and how it might influence supernovae. Dark matter, the enigmatic substance that accounts for approximately 85% of the matter in the universe, does not emit or absorb light, making it challenging to detect. On the other hand, by observing how light and matter around Betelgeuse following its explosion could result in indirect hints regarding the function dark matter plays in the universe's large-scale structure. Betelgeuse supernova will also bring us closer to comprehending the life cycle of stars, particularly how massive stars contributed to the development of elements necessary for life. Supernovae are the primary cosmic events responsible for disseminating heavy elements from all over the universe, elements that eventually form new stars. Studying planets and even living things, researchers in Betelgeuse will advance valuable information about how these components are forged and distributed. The cultural significance of Betelgeuse's explosion is profound. For millennia, humans have looked up at the sky for direction, inspiration, and even meaning. The disappearance of one of the most well-known stars in the night sky will inspire philosophical reflection on the fleeting nature of the universe. Betelgeuse has been a constant presence in the constellation Orion for as long as humanity has the stars. As anticipation builds for Betelgeuse's imminent explosion, scientists and astronomers worldwide are coordinating efforts to monitor and analyze the event in real time. Telescopes across the globe, from Chile's Very Large Telescope, VLT, to NASA's Chandra X-ray Observatory, are poised to capture every stage of the supernova. Space-based observatories such as the James Webb Space Telescope, JWST, and the Hubble Space Telescope will provide critical data on the explosion's infrared and ultraviolet emissions, helping scientists understand the processes occurring within the dying star. One of the key scientific objectives will be to trace the sequence of events leading to the explosion. By closely examining the fluctuations in Betelgeuse's brightness and spectrum, astronomers may be able to confirm early warning signs of supernovae in other distant stars. This knowledge could allow for better predictions of future stellar deaths, offering invaluable insights into the life cycles of massive stars. Another intriguing aspect of Betelgeuse's explosion is its potential to contribute to our understanding of gravitational waves. When massive stars collapse, they release powerful shock waves that ripple through spacetime. Observatories such as LIGO, Laser Interferometer Gravitational Wave Observatory, and Virgo will be on high alert to detect any gravitational waves produced by Betelgeuse's core collapse. If detected, this would mark a historic moment in astrophysics, confirming gravitational interactions in a nearby supernova for the first time. Additionally, the study of cosmic rays originating from Betelgeuse's supernova will provide insights into high-energy astrophysical processes. Cosmic rays are charged particles that travel through space at nearly the speed of light. The sudden increase in cosmic rays from Betelgeuse's explosion may allow scientists to study how these particles accelerate and interact with magnetic fields in space. For amateur astronomers and casual stargazers, the Betelgeuse supernova will be a truly once-in-a-lifetime event. If the explosion is as bright as predicted, it will be visible to the naked eye, even in urban areas with moderate light pollution. Some scientists speculate that, at its peak, the explosion could be brighter than Venus or even rival the full moon in luminosity. This extraordinary sight is expected to last for weeks, and possibly months, before Betelgeuse gradually fades from view. Beyond its scientific significance, Betelgeuse's explosion will likely leave a lasting cultural impact. Throughout history, supernovae have been recorded by ancient civilizations, with some believing them to be divine omens or celestial messages. The sight of a bright new object in the night sky may inspire myths, art, and literature, just as previous supernovae have done in the past. As humanity watches this cosmic spectacle unfold, the Betelgeuse supernova will serve as a humbling reminder of the universe's vastness and dynamism. It will reinforce our connection to the stars, highlighting the interplay between stellar life cycles and the elements that shape our own existence. While Betelgeuse's fate is sealed, its destruction will pave the way for new cosmic formations. The remnants of the supernova will eventually cool and condense, forming new nebulae, which in turn may give birth to new stars and planetary systems. This cycle of destruction and creation is fundamental to the evolution of the universe, reminding us that from death, new life emerges. As astronomers continue their preparations, the world eagerly awaits the final moments of Betelgeuse, a star that has shone in our night sky for millennia. When the explosion finally occurs, it will mark not only the end of an era for this ancient giant but also the beginning of an unprecedented opportunity to expand our knowledge of the cosmos. The Betelgeuse supernova will be an event for the ages, one that will captivate scientists, stargazers, and dreamers alike, bringing us all together in awe of the unfathomable power and beauty of the universe. The entire globe is watching and recording the same cosmic phenomenon from their own perspectives. The explosion of Betelgeuse is not just a one-of-a-kind astronomical occurrence but also a significant event for future exploration. The insights acquired from the supernova will shape how we look at other stars, particularly as we go deeper into the universe with missions to other planets and celestial bodies. Understanding stars' life cycles and the mechanics of supernovae is essential as humanity aims to expand its footprint throughout the universe and beyond. Furthermore, the explosion will rekindle interest in the quest for extraterrestrial life. Supernovae play a crucial role in the dispersion of vital elements for life, such as carbon, oxygen, and other key components, throughout the universe. By analyzing Betelgeuse's detonation, scientists can enhance their understanding of how life's building blocks may move to other planetary systems and possibly spark life elsewhere in the cosmos. Betelgeuse's upcoming explosion is poised to become one of the most important astronomical occurrences of our era. Its supernova will produce an immense amount of scientific data, improving our knowledge of the universe and captivating people around the world. While Betelgeuse's demise will signify the end of a colossal star, it will also represent the ongoing cycle of creation and destruction that governs the universe, a reminder that from death, new stars, planets, and even life itself can emerge. As we brace for this historic moment, all eyes will be on the night sky, anticipating the moment when one of the universe's most formidable forces bursts into view. For researchers and astronomers, the final act of Betelgeuse will be nothing short of awe-inspiring. One of the most speculative yet intriguing aspects tied to Betelgeuse's impending explosion is its potential to illuminate some of the universe's greatest mysteries, dark matter and dark energy. These enigmatic forces are thought to account for the vast majority of the universe's mass and energy, yet they remain largely misunderstood. There is speculation that supernovae, like the one expected from Betelgeuse, may hold the key to unlocking some of these mysteries. A supernova releases a tremendous amount of energy and radiation, and some scientists theorize that these powerful forces could interact with dark matter in observable ways. One fascinating hypothesis suggests that dark matter exists as weakly interacting massive particles, WIMPs. If they exist, their interaction with the energy generated by a supernova could provide valuable insights into their characteristics. Such an interaction would be a groundbreaking revelation, offering the first direct evidence of dark matter, a phenomenon that has eluded scientists for years. Similarly, Betelgeuse's explosion could shed light on the nature of dark energy, the mysterious force driving the universe's accelerated expansion. By observing how light and energy from Betelgeuse's supernova behave, researchers may gather crucial details about how cosmic events like supernovae influence the universe's expansion and their potential connection to dark energy. The impending explosion of Betelgeuse presents a unique opportunity to investigate the life cycle of massive stars, which play a vital role in the cosmic ecosystem. Red supergiants like Betelgeuse are uncommon, making their study essential for understanding stellar evolution. These stars originate from clouds of gas and dust that collapse under gravitational forces, ultimately igniting nuclear fusion in their cores. As they deplete their hydrogen fuel, they expand and dramatically shed their outer layers through powerful solar winds. This mass loss enriches the interstellar medium, paving the way for the formation of new stars. When Betelgeuse goes supernova, it will not only provide insight into its own life cycle but also serve as a cosmic laboratory for examining the conditions under which stars live and die. Researchers will meticulously observe the aftermath of the explosion, where either a neutron star or a black hole may emerge at the core. The nature of this remnant will provide valuable clues about the physical processes that govern the final stages of stellar evolution. Additionally, the explosion itself will offer a wealth of data. The shock wave produced by the supernova will sweep through the surrounding gas and dust, heating it up and causing it to radiate brightly. This light will provide astronomers with clues about the elements synthesized during the explosion, including iron, nickel, and other heavy elements. By analyzing the spectral signatures of these elements, scientists can determine their abundance and distribution, thereby enhancing our understanding of how they spread through space and contribute to the creation of new stars and planetary systems. Another intriguing area of interest is the potential detection of gravitational waves. As the core collapses, triggering the supernova, it may create ripples in spacetime that can be detected by observatories like LIGO and Virgo. These gravitational waves carry information about the dynamics of the explosion, offering fresh insights into the physics of supernovae and black hole formation. Betelgeuse's explosion could also serve as a catalyst for technological advancements in astronomy. The expected surge of observational data will likely push the limits of current astronomical instruments, leading to innovations in imaging, real-time data processing, and analytical techniques. These advancements could benefit a wide range of astronomical research beyond just this supernova. Public engagement will be a crucial aspect of Betelgeuse's supernova, fostering a sense of wonder and curiosity about the universe. Educational programs, outreach initiatives, and citizen science projects can use this event to inspire future astronomers. Universities and physics departments may organize viewing parties, lectures, and discussions to highlight the significance of understanding the cosmos and our place within it. As we await this monumental occurrence, excitement reverberates through both the scientific community and amateur astronomy enthusiasts. The anticipation surrounding Betelgeuse's supernova encapsulates humanity's relentless curiosity and desire to explore the unknown. It challenges our understanding of the universe while simultaneously uniting us in our quest for knowledge. In this sense, the death of a star becomes a powerful reminder of the cycle of creation and destruction that defines the cosmos, urging us to contemplate our own existence and the mysteries that lie beyond. A new era in astronomy. The detonation of Betelgeuse will not only confirm existing theories but also challenge long-held assumptions about stellar evolution and cosmic phenomena. As astronomers analyze the supernova's light curve, they may detect unexpected fluctuations, hinting at processes previously unknown. This could lead to refinements in stellar models and even the discovery of new physical principles governing the life cycles of massive stars. Furthermore, the real-time observation of a supernova this close to Earth provides an invaluable case study. Previous supernovae observed from a distance have given scientists a fragmented picture of these events, often relying on indirect measurements and after-the-fact data. But with Betelgeuse, astronomers will witness the event unfold in unprecedented detail, potentially identifying subtle interactions that were previously impossible to detect. Advanced space telescopes like the James Webb Space Telescope, JWST, and upcoming next-generation observatories will have the opportunity to capture Betelgeuse's explosion across multiple wavelengths: visible light, infrared, ultraviolet, and even X-rays. These observations could reveal crucial details about the structure of the dying star, the composition of its ejected material, and the role magnetic fields play in the final stages of a supergiant's life. Implications for future space exploration. Beyond its immediate scientific impact, Betelgeuse's explosion could influence how we approach deep space exploration. The study of supernovae helps us understand cosmic radiation, an essential factor in planning long-duration space missions. High-energy particles ejected from such stellar explosions can pose risks to astronauts and spacecraft traveling beyond Earth's protective magnetic field. By analyzing Betelgeuse's explosion, scientists may refine radiation shielding techniques for missions to Mars and beyond. Additionally, the shock waves from supernovae play a role in triggering the formation of new stars and planetary systems. Observing how Betelgeuse's remnants interact with the surrounding interstellar medium could give us insights into the conditions necessary for planetary formation. This knowledge might one day assist in identifying exoplanetary systems most likely to host life. The cultural and historical significance. Throughout history, bright celestial events have captured human imagination, often being interpreted as omens or divine messages. The appearance of a new, intensely bright object in the sky, potentially visible even during the day, will likely reignite cultural and philosophical discussions about our place in the universe. Many ancient civilizations recorded supernovae in their astronomical texts and folklore. The 1054 supernova that created the Crab Nebula was observed by Chinese and Middle Eastern astronomers and even depicted in Native American rock art. Similarly, Betelgeuse's explosion will leave an imprint on modern society, becoming a landmark event for generations to come. For poets, artists, and storytellers, Betelgeuse's final act will serve as a powerful metaphor, a symbol of cosmic rebirth, transformation, and the ever-changing nature of existence. It may inspire new works of literature, music, and art, just as previous celestial events have shaped human culture throughout history. Preparing for the spectacle. As we edge closer to the moment when Betelgeuse finally goes supernova, excitement continues to build. Astronomers around the world are closely monitoring the star, looking for the telltale signs of an imminent explosion. Advances in predictive modeling may soon allow scientists to narrow down the timeframe, giving humanity a countdown to one of the most significant celestial events of our time. When the explosion finally occurs, telescopes and observatories across the planet will turn their gaze toward Orion, capturing the spectacle in breathtaking detail. Live streams and public viewing events will make this once-in-a-lifetime event accessible to everyone, ensuring that people worldwide can witness the moment when a dying star illuminates the night sky like never before. A universe in motion. In the grand cosmic dance, Betelgeuse is but one performer among countless stars that have come and gone across billions of years. Yet, its impending explosion reminds us that the universe is alive with motion, change, and transformation. Stars are born, they shine brightly, and they fade, leaving behind the building blocks for future worlds, future stars, and perhaps even future civilizations. As humanity watches and waits, Betelgeuse's final act will serve as a testament to our endless quest for understanding, a reminder that, in the vastness of the cosmos, every ending is merely the beginning of something new.